Bismillahirrahmanirrahim. Today we discuss the topic of discrete mathematics. First is relations, domain and range of a relation, universal and empty relation, inverse of a relation, types of relations. Types of relation is reflexive relation, symmetric and antisymmetric relations, transitive relations, equivalence relations, partial ordering relations. What is relation? Let A and B be sets. A and B non-empty sets. A binary relation and simply relation from A to B is a subset of A cross B. For example, let A is equal to 1, 2, 3 and B is equal to XYZ, and let R is equal to 1Y, 1Z, 3Y, then R is a relation from A to B since R is a subset of A cross B. With respect to this relation, 1 related to Y, yani 1 has a relation with Y, 1 related to Z and 3 related to Y. Domain and range of a relation. The domain of a relation R is the set of R first element of ordered pair which belongs to R, and the relation is the set of range is the set of second elements. The first element is called domain and second elements of any subset is called range. For example, in previous example, the domain of relation R is 1, 3 and range is YZ. Universal relation A cross A and empty relation show this sign. Inverse relation. Let R be a relation from A to B to a set B. The inverse of relation R is denoted by R की power -1 या R inverse is the relation from B to A which consists of those ordered pair which when reverse belongs to R. For example, in previous example, the inverse of relation is y1, z1, y3. Its mean the second in reverse relation the range will be domain and domain will be range place. Reflexive relation. A relation R on a set A is reflexive if A related to A for any A belongs to A, that is if A belongs to R for every A belongs to A. This R is not reflexive if there exists A belongs to A such that A does not belongs to A. Its mean the elements of first place yani domain and range will be same. For example, in any set A is equal to 1, 2, 3, 4, then A cross A 1, 1, 2, 2, 3, 3, 4, 4 is a reflexive relation. Symmetric relation. A relation R on a set A is symmetric if whenever A related to B, then B related to A. That is, if whenever AB belongs to R and BA belongs to R. For example, any set A is equal to 1, 2, 3, 4, then R is equal to 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, 4, 4 is symmetric relation. This relation is called symmetric because a 1, 2 and 2, 1 both are fulfill the condition of symmetric relation. Antisymmetric relation. A relation R on a set A is antisymmetric if whenever A related to B and B related to A, then A is equal to B. That is, if A is not equal to B and A related to B, then B is not related to A. For example, in any set A is equal to 1, 2, 3, 4, then R is equal to 1, 3, 2, 1 is an antisymmetric relation. In symmetric relation, the difference between symmetric relation and antisymmetric relation is that in a symmetric relation, A related to B and B related to A, And in antisymmetric relation, A related to B but B is not related to A. Transitive relation. A relation R on a set A is transitive if whenever A related to B and B related to C, then A related to C. That is, if whenever AB and BC belongs to R, then AC belongs to R. For example, any set A 1 2 3 4, then R is equal to 1 1 1 2 2 1 2 2 3 3 4 4 is an transitive relation. In first three subsets 1, if 1 related to 1, in second subset 1 related to 2, in third subset 2 related to 1, then a 1 related to 1 in first subset, so it is transitive relation. Equivalence relation. Consider a non-empty set S. A relation R on a set S is an equivalence relation if R is reflexive, symmetric and transitive. That is, R is an equivalence relation on S if it has the following three properties. For every A belongs to S and A related to A, if A related to B, then B related to A. If A related to B and B related to A, then A related to C. In partial order relations. A relation R on a set A is a partial ordering or a partial order of set if R is reflexive, antisymmetric and transitive. A set S together with a partial ordering R is called a partial order set or poset. The difference between equivalence relation and partial ordering relation is that in equivalence relation symmetric relation is hold, but in partial ordering relation antisymmetric relation is hold. The difference between both, there is a main difference between equivalence relation and partial ordering relation. Thank you.